Hey guys, this is your learning assistant for Biology 1009. Today I have a short video for population ecology. Population can be divided into two different types. First one open and second one closed. So the open populations, so when individuals disperse from or into a population, these populations are considered open. So if there has to be some movement of population in or out of community, immigration and emigration. But if it's a closed population, there is no movement of populations in and out. And there are two different types of population growth. First one being continuous. So when adults can reproduce at any time, populations have continuous growth. But when adults have distinct breeding seasons, the population growth will be discrete. So continuous adults can reproduce at any time. Discrete growth, there has to be distinct seasons for it. Different patterns that I'll talk about now of growth. First one being exponential growth. So the equation is dn over dt is equal to rn, r representing the instantaneous rate of increase, which is birth minus death, and representing the population size. So the graph of exponential growth do look like this. The line has a curve. It's not a linear straight line. It's not a straight linear line, but it has a curve, but still increasing, and there has to be unlimited resources. Therefore, there's no carrying capacity, so the rate of the growth never becomes zero. It just keeps increases. And there are certain assumptions for exponential growth. The population has to be closed. There has to be constant probability of birth and death. And there has to be unlimited resources. There has to be no genetic structure. There has to be no age and size structure. The population growth has to be continuous. So if you see a graph like this, the population is population growth is exponential. On the other hand, we have logistic growth, which can be expressed in this equation here. dn over dt is equal to rn times 1 minus n over k, k representing the carrying capacity, which means that for this community here, population has limiting resources. So the graph is usually has S shape. This graph doesn't have a distinct S shape, but usually it should be more S. So up from here to here, oops. So from here to here, it seems like there is a exponential growth. It's just keep increasing. But as soon as the growth is coming closer, as soon as it is approaching closer to the carrying capacity, which is 100 on this graph, the line becomes more flat, and then the growth rate becomes smaller and smaller, because the slope of this line is becoming smaller and smaller. And once the population hits the carrying capacity, the growth rate dn over dt becomes zero, because there is no more resources for the population to grow. So yeah, that's pretty much it for logistic growth. At last, I have some regulation factors of population growth. First one is density independent factors. So when birth B and death D do not depend on the population size, they're considered density independent. The examples are floods, extreme temperature, usually abiotic factors. So exponential growth should be density independent, because the birth and death, because there are unlimited resources, the birth and death rates do not depend on the population size. Density dependent factors, if B and D increase or decrease with the population size, depending on the population size, then it is considered density independent factors. So the examples are disease, predators, usually abiotic factors. So logistic growth is density dependent, because due to a limiting resources, birth and death rates do depend on the population size. So that's pretty much it. So thank you.